I want to explain an important technical point in CCIE to you. So this is MPLS. Okay, so MPLS, you can see this is the MPLS VPN network architecture. So MPLS VPN uses BGP to advertise VPN route on the carrier backbone network IPNet, and uses MPLS to forward VPN packet on the carrier backbone network. So it's common layer 3 VPN technology. Okay, so you can see the network architecture. So this is MPLS VPN background network, and this is the site. Site is from our customer, so it's called CE. So CE is customer edge, and this device is called, it belongs to provider. So we will call this device provider edge. So it's PE, and this two device is also belong to PE, and this device is belong to provider. So we will call this device P. Okay, so PE and P are all operator equipment, and CE is belong to customer. So MPLS VPN is belong to L3 layer 3 VPN. So the network architecture of MPLS VPN consists of three parts: CE, PE, and P. So let's see the VPN technical architecture. So MPLS VPN mainly includes the following technology: MPBGP. So what's the MPBGP? Okay, we can see the MPBGP it's responsible for transferring routing information within a site between the PEs. So these PEs, we will use the MPBGP to transferring routing information. And the second is LDP. Okay, so LDP, it's responsible for establish tunnel between PEs. So we need to use LDP. Okay, so it will use LDP tag, LTP label. Okay, so the thirdly is VRF. So VRF is responsible for PE VPN user management. Okay, and the last is routing. So routing table. A routing table includes IGP, stating routing. BGP, it's responsible for exchange routing information between PE and CE. Okay, so I will introduce this part detail. So let's see the MPLS route interaction. Okay, so to realize the communication between different sites, this is site A, site B, and site C, and this is site D. So in order to realize the communication between different sites of the same VPN, so it is first necessary to complete a routing interaction between different sites. So in the basis MPLS VPN network, CE and PE are involved in the advertisement of VPN routing information. So the P router only maintain the route of the backbone network, and it doesn't need to know any VPN routing information. Okay, so the P router doesn't need to know any VPN routing information. So So the publishing process of VPN routing information including 3 parts. So local CE to ingress PE and the egress PE to ingress PE to egress PE. This is egress PE and the export PE to remote CE. Okay, to remote CE. So it has 3 parts. Okay. So let's see the route transfer from ingress PE to egress PE. Okay. So if the CE1 is belong to company X and this is company X, the C3 is also belong to the company X. So if the CE want to transfer this route to CE3, so but the company Y, the CE2 and the CE4 is belong to company Y, but two company one, but the PE1, if the PE1 receive the 2 CE and the route is the same. So how to distinguish the route received from 2 VPN clients? Okay, so it's need to independently save the route of different VPN, and it's need to solve the problem that different customer use overlapping IP address space. So how to distinguish the route? So the PE1 how to receive from the 2 VPN clients. Okay, so we need to know 2 concepts. Okay, so let me continue to talk the related concept about VRF and RD. So let's see what's the VRF and RD. So VRF is related to virtual routing and forwarding. So if the router has the one interface and the interface 1 and the interface 2. So if we configure the VRF on the router, so each VRF can be understood as a virtual local router. Okay, so each VRF can be known as a virtual logical router, and each VRF enabled router can create multiple VRF. So the router can create several VRF, and by default there is a physical isolation between VRF and between VRFs and the main router. So VRF is private network, and the address space of different VPNs may overlap within a certain range. Okay, so we can use VRF to solve the overlapping with a certain range. And about RD is route distinguish. So when CE's IPv4 route enter the global VPN-v4 address cluster, and 8-byte RD is added in front of the 32-bit IPv4 route to become a VPN-v4 route prefix. So VPN-v4 is combined with RD and 32 IPv4. So it's our VPN-v4 address cluster. So even if the root of the customer CE are overlapping, it can be found by addressing a unique VPN unique root distinguish unique VPN v4 routing prefix to solve the problem of advertising overlapping customer route. So let me see if the true CE can transfer the route, it will use the VRF and RD to solve the overlapping customer route. So a BGP neighbor relationship established. So you can see we will establish the BGP neighbor between PEs, so and route and transfer through BGP. So but why we will use BGP in PEs? Okay, so I want to ask you, so in between PEs, why we need to configure BGP between the PEs? Okay, so anyone know? So you can think about it. Why we need to use BGP in MPLS VPN backbone network? So BGP use TCP because the BGP use the TCP as its transport layer protocol, so which improves the reliability of the protocol, so route can be exchanged directly between two PE devices across routers. Okay, and BGP has shown scalability and facilitate the propagation of VPN route between PEs. The routing intra-light neutral transmitted between PE may be larger, and the BGP only send update. BGP only need to send update route, so it's increasing the number of transmitting route without occupying too much link backbone. Okay, so and the traditional BGP4 doesn't support handling VPN v4, but I want to ask, you can see, so the PE we use to the BGP, but how to transfer VPN v4 route between the PEs? So we need to use the MPBGP. Okay, MPBGP. So what's the MPBGP? Okay, so what's the MPBGP? So MPBGP uses address family to distinguish different network layer protocol. So it's not only support the IPv4 address family, but also other address family such as IPv4 address family and the IPv6 address family. Okay. So let's see the route transfer from this PE to egress PE. So it's the CE. So after the PE learn the route from the CE, so it will add the RD. So this is RD and IPv4 32 IPv4. So it's our VPN v4. So after MPBGP transmit VPN v4 to remote the PE. So the remote PE, if the remote PE receive the route from the egress PE, so the remote PE need to import the VPN v4 to create VPN. It's need to import the correct VPN, the correct site. So, such as if the PE true receive the root. So how to the PE true? How to know transfer this root to company X and the company Y? Okay. So which root is for customer X and which one is for customer Y? So PE true, how to distinguish it? Okay, so MPLS VPN it will use the 32BGP extended community attribute. It's called root target VPN target RT root target to control the publishing and the receiving of VPN routing information. So let's see the RT. RT is important point for our MPLS. So the RT has two type. It's the export RT and the import RT. So what's the export RT and the import RT? So export RT is carried as an extended community attribute when VPN v4 root prefix are advertised. So such as if the PE want to transfer the root to the ingress, so it will carry the export RT. So it will carry the export RT. So let's see this is RT, and the import RT is the local VRF is used to receive the VPN v4 root prefix with the specific RT value. So let me explain it for detail. So how to use the RT, the export RT and the import RT. So if the company X the export RT is 101 and the site X the import RT is 101 and the and the C1 export RT is 101. So if the export is the same as the import, so the root will be import to the correct site. Okay, so this is the RT, and if the import RT is not the same export RT, so the root won't be learned. Okay, so let's see the continue. So what the MPLS? So how MPLS work in this MPLS VPN backbone network? So the MPLS VPN backbone network will run LDP. It will run LDP between PEs and the P. So this part will run the LDP. So it will exchange public network label and establish LSP. It will establish LSP tunnel. So public network tunnel. So this part will relate to two type label. It's inner label and outer label. So what's the inner label? So inner label it will distribute by NPBGP of PE for VPN root. the PE determine the VPN to which the data belonging to according to the inner label. Okay, so the PE determine the VPN to which the data belong to according to the inner label. And when the PE transmit the VPN v4 route through the MPBGP, it's BGP. It will carry the private network label to distinguish the data of different VPN. So the outer label is distributed by LDP to the next hop, generally an interface address of PE. So the outer label is distinguished by LDP to the next hop route by the VPN, and the P forward the data to PE according to the outer label. Okay. So in this part, you need to know what's the inner label and the outer label. Okay, so let me summarize the configuration of the MPLS. So in MPLS VPN routing information need to transmitted between PE and CE and between PEs. So BGP, IGP, and static routing can be used to exchange the IPv4 routing information. So we need to configure BGP, IGP to transfer IPv4 route between PE and CE. Okay, and the PEs exchange VPN v4 routing information through MPBGP. MPBGP. So we need to know the VRF and the RD. So we will configure the RD. RD and IPv4 is our VPN v4. It's our VPN v4 prefix route, and we need to use RT export target and import target to control the receiving and the publishing of routing information between PEs. And we need to use the MPLS it's including inner label and outer label during data forwarding, so which is used to the PE to distinguish data of different types, different VPN. Okay, so these are all about our MPLS, but MPLS have many knowledge point. So I will show the MPLS other point next time. Okay, so today